Hi guys, and recently I saw this FNIRSI LCR-P1 transistor tester on sale, and I purchased this one myself. I don't seem to get free stuff from them, and in fact I've emailed FNIRSI several times. They never seem to reply to any emails that I send them, typical for Chinese manufacturers. And this thing over here, I have done some tests on it, and the answer to the question is it ready for prime time? Absolutely not. It's full of bugs. It is absolutely not very good. In fact, it is very similar. It must be running similar software to what these older ones, multifunction tester TC1 is, but this one is much better. So if you're going to buy a transistor tester, just buy the old version. It's half the price and it is much better. Now, they spent a lot of time making it look fancy, and it is actually, thinner and smaller than the older version, you could say. But what they've done is they've made it is slower than this one, and not as accurate, and there are many components that it just can't handle, and that includes Schottky diodes. It cannot read them at all. So I have a bunch of components laying around here. You can't see them all, they're all over there. So let's have a look what we can do. Now it comes with this little device over here, which is one of the reasons I wanted to try it out, because the only one I have that has SMD component capability is this one here, and this one here is quite inaccurate, but nevertheless it does some things that these guys don't seem to do, and it has that facility. And I thought, well, it'd be nice to have something like this that also has, this what doesn't fit there, this little module can be removed, so that's kind of a nice feature. And you can plug in sort of an SMD section there, and I've tried that out. That works okay, but it has some real limitations. Many components it just can't seem to analyze at all. So let's have a look what we can find out. Oh, and actually before we begin, this device over here, which is the Atlas DCA-Pro 75, is actually a professional component tester. It's 4 times the price at least of these Chinese versions, and this is made in the UK. And if you email the people there, they will respond immediately, and you can get spare parts for it, and you can even have it calibrated and so on. So this is what you would use if you are professionally involved in electronics, and also, or you want to have something that is more workable. It also has a software with it, and you will see it over here, and you can actually run it from a PC. I can hit the test button there, and I can just leave the thing laying there. The display on it is kind of small, but when you see it, we'll use it and show you on the PC, what it actually does for reference. So let's try something here. I've got some components laid out here from right to left, so we will just randomly pick those up. Now, one thing to notice with these things here is you see they've got little sockets over here, and you see it on this one as well. It's got numbers there, 1, 2, 3, 1, 2, 3, and these 3 ones over here, KAA, they are only used for Zener diodes. And if you put an ordinary diode in there, it'll say unknown components or it's faulty, so you keep that in mind. On this one over here, that's the same thing. There's a little bit of glare there, but you can see it. Those sockets don't work at all unless you hit the Zener button over here on this one. Now, the first thing you'll notice on this thing is when you first turn it on, it actually straight away goes to this unknown, no component or damage. I mean, this is really kind of poor. That message should say, okay, press the test button to start testing or something of that nature, because that is really confusing. Every time you put something in there, and several times I have noticed that even if I turn it on and I push the button the first time, sometimes it doesn't seem to work and it comes back with unknown components and you got to hit it the third time. So over here you see I put an LED in there and the thing just says diode and forward voltage 2.67 volts. So I guess you know that it's an LED, but it doesn't tell you that, which is very similar to this guy here, which is obviously an ancestor of it. If I put an LED in there, it also says diode 2.74 volts. One thing you'll notice is that the old one is way faster than this FNIRSI thing. It is very slow. And you will notice that, for instance, I've got two transistors over here, just ordinary BC548 transistors. If I plug that in here, and I plug this one in there, these are the same kind of transistors. I hit the button straight away. So this one came back straight away with what it is, very quickly. This one, because as I said, you hit the button, it doesn't start testing, comes back with that stupid message. So let's do it again. I'm going to hit both of them. You see how much quicker the old one is? Takes 2 or 3 times as long. So that's yet another thing which is annoying about that FNIRSI thing. It's slow. So both of them were able to, of course, see what kind of transistor that was. This is a 2N322 transistor. It's kind of, let's put it on the Atlas one to see what it really is. It's kind of a weird old transistor. I don't actually know. Usually those low numbered ones are old. They've been around for a long time. So let's have a look. Software, I'm going to hit the test button on the PC. Okay, as you can see, it has quite a lot of information there. It actually tells me that it is a germanium transistor, which is important to know. As I said, it's an old transistor. It has leakage current, as you would expect from a germanium transistor. I'll make that window a little bit bigger here, and I'll have to move it on the screen as well. Gives you that DCA-Pro gives you a whole bunch of information about it. Talks about the leakage current for germanium types and so on, and information that might be of interest to you. As I said, this thing is a professional, tester. It also allows you to generate curves, and this is the collector current versus the voltage VCE. You can change the parameters here. You can tell it to go from 0 volts to 12 volts in this point and so on. I'm not going to change it. I'm just demonstrating. There's a little circuit here is how it determines what the test circuit that it's using. And if you press start, it gives you those curves that you often see in data sheets. That allows you to determine whether the how to use the transistor, you know, what sort of voltages to set it on the bias and all that kind of stuff. So there you have it. So let's first plug it into the old one here. Let's move this one out of the way. Okay, this one came back. This is the Germanium transistor, remember? And it says HFE49. You can kind of tell that it is a Germanium because it's got VBE 216 millivolts. Yeah, timed out already. But you can see that it has quite a bit of information there. Now plug it into this thing here. Again, it has much less information there, and I don't trust those values here. It says VBE 115 millivolts. I don't know. It doesn't tell you. It tells you it's a PNP transistor, but it doesn't tell you that's germanium either. So that's common, but I think the old one did a much better job. I'm actually wondering what this thing does. This is a different type of... let me arrange these legs a little bit. Okay, this one says also it's PNP 211 millivolts. I trust that more. I don't like this one said 119. I think that's probably in error. 13 milliamps. It gives you a bit more information as well. So that's, to me, that's kind of like a fail on the FNIRSI thing. Didn't do a great job. Okay, so next component that we have here is I'm gonna hook it up to the Atlas DCA-Pro to really see what it is. Let me get the... Okay, this is actually a package with 2 diodes in it. And they are 453 volts. But number 2 is kind of weird. It says forward voltage 0 volts. Test that again. That looks kind of a bit strange. Let me rearrange these little legs a little bit here. DCA-Pro is not perfect either. It does get confused occasionally. Not as much as the cheap Chinese ones, but it does. I can't see how it can have forward voltage 0 volts, but nevertheless. Let's have a look what the other ones say. This one says 2 diodes, 467 millivolts each. So I think that's probably a bug in that little Atlas DCA-Pro. Let me see if if it's just a software. See, you can actually scroll the thing down as well. It's a software. It's not displaying it properly. There's a bug in the software, obviously. Here, this is the number 2, so both of them are 445 volts. Yeah, that's interesting. Okay, so it's not the DCA Pro, it's actually the software that is not displaying the voltage correctly. So it's a software bug rather than a controller bug. Okay, well, in any case, that's what that does. This is what it does sometimes. You push it and it says unknown damaged components. As I said, the firmware is full of bugs. Push it again and it'll probably come up okay. No. Okay, fail. It can't test the double diode. As I said, that FNIRSI thing is full of bugs. It is terrible. Okay, well, this thing is actually telling me that there are two diodes there, 482 millivolts, 482 millivolts. It cannot identify dual diodes in one package. It's a fairly common, but that's a fail. I'll put it over there. What is this? Oh, this is an interesting thing here. It thinks it's two resistances. If you plug it in here, this one thinks it's two diodes. And if you put it on the DCA Pro, easiest to bring up the software again, and I'll hit the test button on the PC there. Okay, so what is this thing here? Oh, it's got MA7D50 on there. I thought it was a oh no, it's not a, that's in fact what it is. It's actually two Schottky diodes in one package. That's what it is. And again, there's a bug there in that software. So it's forward voltage 1.8, 180 millivolts. That shows you that it is a Schottky diode. Again, this is diode junction 1, diode junction 2, also 1.81 volts. So as I said, it's correctly identifying that. Now when you plug that in here, let me get rid of this light. Thinks it's two resistors. Plug it in the older one. It correctly identifies it as two diodes. The old one works, the FNIRSI one failed. Another failure. Okay, what else have we got? Here is an old-fashioned glass diode. It's actually probably got a little whisker in there or something. It's got OA7 something or other. It's an old diode here. It's a diode junction forward voltage, so it's a silicon diode. Pin 1 and pin 2. It's again annoying. You push the button, it says test, and it always comes back with that stupid message. Again, it can't read this diode. It says it's a resistance. It's really bad. It's like, just going to change the size of that window a bit here. So I can move it out of the way a bit more. Okay. Again, another fail. Now this one over here, the old one, shouldn't have a problem. Yep, diode, no problems at all. So that's another fail there. Here we got a transistor. This is also a germanium transistor. It's an AC-126. The thing is about 60 years old. Came with a Philips electronic engineer kit in those days that you could buy in order to experiment with components. It was aimed at young people, and that's how I got into electronics when I was like 10 years old or something like that. Okay, let's have a look now. I've still got a few of those components left. Okay, germanium, BJT, indeed, all that stuff correct. Got quite a bit of leakage current, 1 milliamp, because it's a germanium transistor. In the old one here, the old one, as soon as you hit the button, it's testing, you know, comes back very quickly. It says BJT, PNP, and BBE is 105 millivolts, IC3, and so on, and HFE 185. These testers I don't think are as accurate as my DCA-Pro there, but in any case it was able to read it and come back with something. This gives you much less information. It says HFE 15, which is incorrect. It just cannot do germanium transistors very well. But and VBE 27 millivolts is kind of garbage information. So that's actually a fail. Okay, now here, this is kind of interesting. This is what I thought I had earlier. This is the actual 7805 voltage regulator. Oops, that's not what I wanted to do. It won't be able to come back with thinking about it for a long time. And it says it's a resistance between pin 2 and pin 3. This old one will also not be able to read it. They just don't know how to deal with those things. But that's the better result, unknown or damaged part. It shouldn't say that it's a resistance. But I really, if they based it on this old one here, it seems to be very similar in a lot of respects. They really screwed up the firmware, haven't they? Okay, I've got it connected to the DCA-Pro. and it should be able to tell me what it is. Yep, it's a voltage regulator. It's 5.15 volts and so on. So again, the professional component testers, they can handle that, but these Chinese things they can't. So, but I won't count that as a fail because they are just not built for that sort of thing. Okay, here I have a diode. Okay, standard diode, silicon diode. Oh. Okay, standard silicon diode when you plug it into there. But what really is it? So you hook it up to DCA-Pro. And it too says it is a diode. However, if I now hook it up to the A and AA socket, aha, it's actually a Zener diode with 14.3 volts. And the DCA-Pro for some reason couldn't work that out either because it's more than 12 volts. It has a limit, it's a 12 volt battery in there. Now, what happens with this one here is that you have to plug it in, and you got to plug it in the right way around, cathode, and same as this one, but this one I didn't have to do anything. I just pushed the button and it recognized it. On this one, however, I've got to push this, got to turn it on first, hit the Zener button, and then do a test. And now it also was able to tell me that it's 14.07 volt Zener diode. Now this thing, they have upgraded it. Like, I'll give you an example here. This is a high voltage Zener diode, and that's one of the things that they mention in the sales information there. Okay, now it can work it out. All right, so 32.6181 volts. So this one can do the high voltage Zener, and you plug it into this one, and it won't be able to do it because it can't do the voltage that high. It bombs out at about 14 or 15 volts. Yep, see, unknown of damaged parts. So that's one thing where FNIRSI is able to tell me what a high voltage Zener does, and none of the others can. Also, if I plug it into this one too, it's not going to be able to do it either. So one win for the FNIRSI. It just again reports it as being a standard diode. Now here we have a component that is marked RS2037. I think it's an old Radio Shack thing, but yeah, I think it's a field effect, the J-FET. So no problems with that, because you lots of information too. And I think they will all report the same thing. I haven't looked up the data sheets, but P-channel J-FET. Okay. J-FETs are good. Now here I have some components that are, this is definitely what is called a Uni-junction Transistor. And these things were popular in the 1970s. They were used for oscillators and things. But no one uses those anymore, and I don't think they're even made anymore. And it thinks it's 2 diodes. And in fact, even the DCA-Pro that can't handle it. It'll say a similar thing. So that is not, we won't blame it for that. It doesn't know what it is. Now, what have I got here? An old little ESC, a little transistor in a little metal can. DMP transistor. It says HFE0, i.e. 1 microamp. So you can already see there's something going on there that is not really what we would be expecting to see. Aha, because it's not a transistor, it's a thyristor. That's what it is. And you see, this FNIRSI thing cannot actually recognize a thyristor. But this is correct. That is what it is. So that's another fail. And just to double check here. So you can see why I'm saying that this thing is not ready for prime time. The software in it is buggy and it is just totally useless for any specialized components. If you're only testing little silicon transistors with it, yeah, it'll work. But Schottky diodes don't work, thyristors don't work. Again, they're telling us that it's a thyristor over here, which is correct. And here is a bigger one. BJT NPN. Could be what it is. Let me see. This is like a power transistor. So that's what it is. It's got a TO220 can on it. But no, that's not what it is. It's a Triac. Another. Even this one got fooled, and of course if I plug it in here also it's not going to be able to recognize it. Yeah, it also thinks it's some sort of transistor, but it's not. It's a Triac. So that's another fail. But both of these failed. As I said, these little Chinese transistor component testers, they have limited use. They're really only for hobby use and not for professional use. And I've seen other YouTubers, you know, raving about these things, but they probably either got the things for free and I feel like they got to say something good about it, or they don't know what they're talking about. All right, here we got an IGBT. Now an IGBT is a component that is often used in power supplies, and it actually has a gate like a field effect transistor with very high input impedance, but the output of it is like an ordinary bipolar transistor. It's got a collector and an emitter, so it's like a hybrid device. It thinks it's a diode. Incorrect. This one over here, same deal. It's actually a surface mount component, so I have to use these little leads on it. Let me push this down. So you can see what I'm doing. There we go. Unlink. Two legs. Oh, come on. Two legs and a third one has to go on there. It also thinks it's only a diode. But you hook it up to the DCA-Pro, it should be able to recognize it properly. Yep, N-channel enhancement mode IGBT. Okay, because that's exactly what it is. And it's a brand new device, there's nothing wrong with it. Now here is a big IGBT, and for some reason they seem to be able to recognize this one. Some sort of limitation in the firmware that the little one, the smaller one, cannot be recognized. Yep, this one is able to recognize that it's an NE-IGBT. So this one it was able to recognize. Interesting to see if this thing here has got more limitations too, and it's very inaccurate. And it claims to be an ESR-02 Pro, but forget it, ESR is always 0. But it does recognize it though, IGBT, okay? And I believe this one can do it as well. But again, I'll have to use the little leads because it's too fat to fit in the holes. Yep, it is able to recognize the big one. But why the heck they translated this from Chinese? Probably tube and IGBT. I mean, tube means nothing in English. Okay, so that brings us to capacitance. And as I have said earlier, I don't tend to use these component testers for capacitance, but let's visit it anyway and have a look what they do and what the deal is with capacitance, in fact. So on the screen you will see a data sheet which is for a standard electrolytic capacitor, you know, those little cans with a true hole that have been around forever. And we are going to compare 100 microfarad capacitors. And if you look at the data sheet here, there's a 10-volt one there. Ours are higher voltages, and that does make a difference. The higher the voltage, I think the lower the ESR usually. But gives you a bit of an idea anyway. But you will see ESR quoted at 100 Hertz. Because those old-fashioned electrolytic capacitors, and then underneath this table there was a comment that if you're using 120 Hertz, then you'd have to multiply it or divide it by 0.098 or something like that. I can't remember. I'd have to go and look at it again. So again, showing you that ESR actually changes with frequency, and the reason is that it actually includes the capacitive reactance of the capacitor. Now what they tend to do is they use a higher frequency with modern capacitors like 100 kilohertz to make sure that the capacitive reactance is insignificant when it comes to measuring the ESR. However, on these particular type of capacitors, they can't go up to 100 kilohertz. They just don't work anymore. So that's why they are quoting 100 hertz here. Now, if I bring up a datasheet for a solid aluminium capacitor, or to be more exact, a hybrid polymer aluminium electrolytic capacitor, these guys are much more modern and they are aimed at things like switch mode power supplies. Now you will find that the ESR and all the values are quoted at 100 kilohertz, as I said, for that reason, and they can handle a much higher frequency. So therefore, it all depends what kind of capacitors you're talking about, and it depends on the frequency that you're going to measure them at. And these component testers don't tell you what kind of frequency they're measuring at. In fact, they're not measuring at any frequency. To show that, this is the waveform that the FNIRSI LCR-P1 outputs when it's measuring a capacitor. And what you will find is that it first sends out a bunch of pulses here, and I think that is probably to do with trying to find out what kind of component it is looking at. And then there are several curves over here and some discharge cycles, which we'll expand it in a minute, which looks like capacitor charge cycles. Then it goes into a mode where it tries to do the same thing in a negative fashion. This is actually negative and that's positive. This is 0 volts here, so it goes both positive and negative. And then finally, when it's finished, when it does this beep, there is some pulses over there, which I'm not quite sure what the aid of that is. So this is an image I captured on the oscilloscope. The same thing you looked at before, but now we're expanding the positive side of it. As I said, there's a bunch of pulses at the beginning, and then this is a roughly 100 hertz pulses. They're not very fast. This is expanded over here, and you see there's a curve there of, it's like when a capacitor first gets charged, you know that it uses more, absorbs more current than when it's fully charged. Now what you're looking at here is actually, I put a small value resistor in series with the capacitor as it was connected to the component tester, so that we can see the voltage on the resistor, which actually equates to the current that is flowing through it. In any case, it then sends a negative pulse to it, which presumably discharges the capacitor, I guess. And then there is another charge curve, but now it doesn't have any pulses associated with it. And when that is complete, it actually goes and does the same thing, but now in the opposite polarity. So I guess if you have a polarized capacitor like an electrolytic, maybe it's trying to work out where the positive and negative is, and then use the correct readings for that capacitor. I don't know, I'm only guessing. In any case, what you're seeing over here is not the actual way that a capacitor should be tested for ESR. Obviously, you can measure the charge and discharge curves or whatever of capacitors. That is mostly how I believe multimeters actually test capacitance. You can then determine the capacitance, and in fact I have found that these component testers are reasonably accurate with determining the capacitors of a capacitor. But the ESR, they cannot accurately determine, and I believe this is similar to the original guy, I think he was German or something, when the original very first component tester he actually designed, and he had a section in the white paper that he did on it that the microcontrollers that were available were not fast enough to output a 100 kilohertz sine wave so that ESR and stuff could be measured correctly, and that he found a way to do a rough approximation of ESR using this kind of method. And I believe what I'm seeing here is that these guys are doing the same thing, hence the ESR is not very accurate. Now this thing over here, which is also not a very expensive piece of equipment, I think they sell for around $40 or thereabouts. I have no idea how accurate this thing is, but what I can tell you is that it says 100 kilohertz in circuit tester. So in other words, you're supposed to be able to measure a capacitor while it's still in circuit, and the way that they do that is they output a very low voltage, like 100 or 200 millivolts, so that if you got it in circuit, that the actual semiconductors in the circuit won't be triggered. However, of course, there could be other capacitances there, and I don't think that measuring stuff in circuit is a great idea. But in any case, this guy, if you look at the waveforms that it generates, so this guy does actually output that 100 kilohertz signal, as you can see, 100.32 kilohertz, and it looks like a sine wave. It's a little bit distorted because this has got like a 10 ohm resistor or something in series with the capacitor, and the actual current flowing through that resistor is dependent on not just the capacitors of the capacitor but also its inductance and what have you. So therefore the current that flows wouldn't necessarily follow the exact sine wave pattern, but the device does output that as a sine wave. Okay, so here I have a couple of capacitors that we can use for testing. They're all 100 microfarads, and this one is 35 volts, this one is 25 volts, I believe. Yeah, this one is 16 volts, and this one over here is also 16 volts, 100 microfarads. This one here is actually 22 microfarads marked as. In any case, that's what we're going to do. I'm going to hook up one of these one at a time, and we will see what we can work out on the LCR meter. Okay, so we have this 100 microfarad electrolytic hooked up, and at 100 hertz we are showing 113, nearly 114 microfarads, and we are seeing a phase angle of 87.35 degrees. If it was a perfect capacitor, it would have minus 90 degrees. Minus means it's capacitive. So this particular capacitor is working at that rate, and if we go to ESR, it's reporting 0.65 ohms, which is not bad for an electrolytic like that. I think it's made by Sprague or something like that. Probably a reputable company. Anyway, if we now change the frequency to 100 kilohertz, the ESR now is 0.24, but it's only reporting 14 microfarads. So it is no longer very effective. As a capacitor, the inductive component has started to rear its head, and you can see that if you look at the phase angle, only about 25 degrees instead of 90. So, but it's still working at a as a capacitor actually. So what we have is, this is the 35 volt, and we have, let's go back to Hertz. So if we were filling up that data sheet, we could say at 100 Hertz we got 100, let's call it 114 microfarads, and we have 87.31 degrees, and we have, but the actual ESR, we want to be able to get it at 100 kilohertz, and we can put down 0.24 ohms. Okay, so that's what you would expect to see on that data sheet. As you said, the capacitance was at like 100 hertz or 100 or 120, and the ESR would be at 100 kilohertz. And this one is actually not doing too bad either. It's got 17 microfarads, but its ESR is 0.5. And similar sort of deal. I'm not going to bother with the and it's got 97 microfarads. That's the 16 volt one. Okay. And we got this little solid aluminium one here. 109. Microfarads. And we look at its this one is much closer, as you can see, minus 89.14 degrees, getting close to a more perfect capacitor. And when we go to -100 kilohertz, we're actually seeing minus 77, so it is a much more pure capacitor. However, we are only interested in the ESR right now. 0.01 ohms. So that is pretty good. So let's use these three. Oh, well, we can also look at this little tantalum one while we are there. This is at 100 kilohertz. It's showing 11.7 and 0.26 ohms. we've got 21.9 microfarads. It's 20. Very slow, this FNIRSI thing. It claims to have 122 microfarads, which is more than what we got from the LCR meter, and ESR 0.4, which is also almost double. Capacitors 122. So I don't know, I think it was similar to what the other thing said. Now this one over here, (115 microfarads, which is closer to what we got in an ESR of 0.26. It actually reflects much closer to what we got from the LCR meter, 0.24, 0.26, and 115 instead of 114. So that's actually a good reading. This one, (108 microfarads), we got 97, and we have a 0.76, and we got 0.52. (102) and 0.6, and that is this one here. Got a little bit more on the capacitance, and we got a little bit more on the, but it's not really out of bounds. That looks like this thing beat it again. Solid aluminium one. (115), and here we got 109, I think, and ESR 0.11, and we got 0.01 on the LCR meter. So that's quite a bit out. Now this one is actually telling us 109, which is exactly the same as we got from the LCR meter, but this one said 0.01 ohms, and this one actually says 0.00 ohms. I guess 0.01. Let's do it again. Usually you get slightly different readings each time you push this button on these things. Oh. Oh, now it did come back with 0.01. Now this one here, of course, can also test this tantalum one on account that it has this SMD pad on there. This is a 22 microfarad capacitor, but it seems to take quite a long time. 22.5, oh that's good. ESR 0.47. Again, it's kind of double than what this one is reporting. I can't test it on this one very well unless I connect leads up to it, and when I do that, the leads will have inductance and capacitance. I'm not going to get a great reading. In any case, this thing again seemed to have been beating this newer one. So that's what we have. Obviously, if you want a component tester, just buy the old multifunction tester TC1. It's better and half the price. Okay, as a conclusion then, I cannot recommend this thing. I would not buy it until they fix the firmware on it or whatever it is that stops it from working effectively. These are all the components that it could not identify, but that this older version could identify well. And an older diode, Schottky diode, a double diode, and a double Schottky diode, and germanium transistors of various types, and even this little transistor here, and of course an IGBT that's not actually laying here. I already put it away, that it couldn't measure. So this is not very good, and also it seemed to be less accurate on the capacitance, if that's of any importance to you. And it is double the price than this guy here, and the only factor that it has that the other ones don't have is that it has a Zener mode where you can actually measure higher voltage Zener diodes, but that's all. That's it. Doesn't have anything else going for it. So that's it. Disappointing, but that's the way things go. I'll see you guys later. I hope you will like and subscribe, and I will do something else next time. Bye bye.